Hello everyone, you're welcome to this lesson. Today's class we're going to talk about plotting graphs. So it's very important that we know how to plot graphs because in our WAEC examinations, we are going to meet graphs. Mute your mic, please. Mute your mic. Okay. We're going to meet graphs in our WAEC examinations in physics and in mathematics. We'll have to be asked to plot graphs. So now there's something I also want us to understand, that in physics is divided into practical and OBJ, essay, and practical. Now this practical alone is more than 50%. In fact, practical is 60%. And in that practical, you're going to perform two practicals, either in electrical, light, resistance, or mechanics, or optics. Those are the three areas you're going to do. So any of them that you choose, you'll be asked to plot a graph. And you're meant to answer two practicals, two questions. And those graphs are the major part of the examination. Also in mathematics, you have a compulsory question where you'll be asked to plot a graph, which will cost you about 10 marks of the examination. So learning graphs is very, very important, whether you are an art student or also for this our class today, we will need a graph sheet. How many of you graph sheet? So you need a graph sheet, you need your pen, you need your paper, so that we can solve problems in terms of graph. Okay, now before we go ahead, I will okay, he's joining. Somebody else is joining the meeting. Okay, so now before we go ahead, I want to give us some introduction into what graphing means. I want to give us some introduction into what graphing means. Okay, now let's go to this section. So the title is plotting graphs. Plotting a graph. Plotting a graph. Okay. So if you can see my screen, you can send a chat. If you can see my screen, you can send a chat. Okay. So now a graph is a physical representation. Is a physical representation. A physical representation of mathematical expressions. Equations, rather. Okay. So if you have an equation, whether it's a linear equation, please mute your mic. Kindly mute your mic. Thank you. So now you have different kinds of equations. We have linear equations. We have quadratic equations. And we have other polynomials. Polynomials are equations that have different orders. Okay, so linear equation is one order. Quadratic equation is two order. That means linear equation contains to be something like this: 2x plus 1. This is a linear equation. Quadratic equation could be something like this: x squared plus 2x plus 1. Polynomial has to do with other what? Other levels of the equation. Example, you can have y equal to x raised to the power 4 plus 2x cubed, etc. Okay, so these are equations. So now how do we observe how these equations behave physically? Is by plotting a graph. What is the purpose of an equation? An equation is linked to the motion of an object, the motion of an object, or the motion of what? Part of matter. Okay, it is used to observe increase or decrease in the behavior of the object. Okay, in the object's behavior. Okay, so for instance, maybe we have a car. We have a car moving, right? Let's okay, and then at different areas we experience different distances, we experience different speed. Good morning, sir. You're welcome to this class. Good morning, sir. You're welcome to this class.
Yeah, good morning, man.
Okay, I have already started because I know this kind of thing. If you don't start, nobody will join. So I've started and people have been joining, some have been leaving. So I've started. Thank you.
All right, man.
Okay, so please let's kindly mute our mics. If we have a question, we can unmute. Okay, so now I'm trying to explain why we have equations and what equations are used and the purpose of plotting graphs. Okay, plotting graphs, I said, is a way to observe the motion, the movement of an object or a particle. Let's observe how this particle is moving, whether it's increasing in speed or it's reducing in speed, or we can even use it to observe growth of a human being, population growth. Okay, it is used to do so many observations. So I told us about, for instance, we have a vehicle moving at various speeds, at various times and distances. Okay, so we can decide to represent the motion of this object as what? Y equal to 2x plus 1. We can decide maybe this is how the object is moving. Y stands for what? The distance of the object that the car has moved. 2 stands for the gradient, the slope, that's the increase. Okay, while x stands for what? What does x stand for? Time. The time. Okay, 1 stands for the intercept. What is intercept? Intercept is what distance the car was at time 0, when time is equal to what? 0, or when x is equal to 0. That is what it means. So now let's go ahead. So now remember, I told you, for those of you that are just joining, I told you that there are different kinds of equations, and I told you that graph is a physical representation of mathematical equations, and there are different types of equations: linear equations, quadratic equations, and other polynomial equations. So now let me use a simple example for us to know how to plot graph. First of all, when you're plotting a graph, the steps that you take. First of all, you have the equation that will be generated. Either you will generate the equation or it will be given to you in the examination. Okay, so let's try y equal to 2x plus 1. Okay, so now that's step 1. Identify the equation. Step 2, draw a table of values. Okay, so if you are giving an experiment, if you are doing an experiment, you will be generating values from that experiment. You'll be giving values from that experiment. So if you want to draw the table of values for y equal to 2x plus 1, you also be giving a range. Okay, so they could tell you find the value of y when for x equal to what? -3 to +3. That is the range. Okay, so they are trying to tell you that you're not going to plot your graph outside of this range given to you from -3 to what? 3. Okay, let's say -5. Let me say -5. -5 to 3. Okay, to 5, sorry. Let me delete this. -5 to 5. Okay, so we're going to draw a table of values. Is it your table of values that you will use to generate your graph? Okay, is your table of values you use to generate your graph? Okay, if you're understanding me, if you're understanding everything I'm saying, please write in the comment section. If you're hearing me, write in the comment section. Okay, so we're going to generate a table of values for this equation. For this what? Equation. Okay, so you will draw a table, something like this. The table will be something like this. Just a table with 2 columns. A table with 2 columns. Okay, so you draw all the lines that you want to be, all the spaces you want. I will tell you what to do. Just watch me. When I'm through, I'll give you opportunity to ask questions. Some of you joined late, but this call is being recorded right now. In case, but I will try to still go over 1 or 2 things. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 10, 11. How did I get this number? How did I get this number? Remember, the equation is y equal to 2x, right? 2x plus 1. Y equal to 2x plus 1. And our range of values is find y when x is equal to -1, -5, 2, plus 5. So what are the ranges? The ranges are starting from okay, let's say this is x and this is y. We'll start from -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. What I'm telling you now is WAEC standard. Okay, during when you are giving the questions, you'll be giving an equation and then you'll be giving a range. You'll be giving a range. They will tell you derive the values of y, or the values of, it might not be y, it might be any letter. It might be period. Find the period. Okay, in a pendulum, find the what? Period. So they will tell you how many oscillations. Okay, how many oscillations. So it could be anything. It must not be y, it must not be x. It can be any letter. It could be a question asking you to find what? The degree. The degrees, okay? If it's for optics, it might ask you to find the degrees for different what? positions, depending on the experiment that you perform. So now, this example I gave you, I said, for y equal to 2x plus 1, find the values of y when x is all these functions. When x is all these functions. Okay, so here we are. Let me extend this sheet. I will extend the sheet so that we can have more space to do what we are doing. Okay. I'll zoom in. Zoom in. I believe we're all seeing what is happening. Okay. Thank you. Okay. I will try to shift this table to one side. Undo. I'll try to shift this table to one side. Trying to shift this table to one side. Sorry, I have to move everything so that it will look more orderly than it's looking right now. Okay, let's go ahead. So now I told you steps to plot a graph. We have the equation given. We'll first of all draw the table of values. We'll also be given a range. Okay, so for this equation, we are finding the value of x. For this range, x, when x is equal to -5 to 5. So I've drawn the table. I've slotted in the values of x. So now to find the values of y, I'm going to calculate. You will have to calculate the value of y by substituting the values of x at all these points. Okay, so we'll find the value when x is equal to -5. We'll find the value of y as what? 2. We substitute the value of x inside what? Y. So how do we get the answer? 2 times -5 gives us what? Gives us -10 plus 1. So our answer will be what? -9. So we'll go over here and write 9. The value of y at -5 is what? 9. Are we good? Drop a comment in the comment section. If you are okay, say I'm okay. Or you can use an emoji, any of the emojis. Okay? If you are okay with what is going on, drop a comment. Drop a comment. Thank you. So we'll also look for x when x is what? -4. Okay? So we'll take that same equation and we'll slot in -4 in. Okay? Then we'll have what? -8 plus 1, giving us -7. So we'll go back to the table and we'll slot in that value. Sorry, this is -9, -7. What do we do next? We'll keep on solving till we get all the values for each of these tables. So let's quickly run through quickly. Okay, so we'll have x equal to -3. So say y equal to 2 plus 1, giving us what? -6 plus 1, which is equal to -5. So we'll come here and slot in -5 into this equation. Okay, I'm seeing a progression. So I can just simply write it. I know that this will be -3, right? I know this will be -2, -1. Okay, 0. I know this will be 1. Okay, so it's an arithmetic progression. It's an arithmetic what? Progression. I know this will be what? 3. I know this will be 5. If you do your calculations, you can check whether I am correct. Sorry, 0 gave us 1. 0 gave us 1. 1 gave us 3. 2 gave us 5. 3 gave us 7. 4 gave us what? 9. And 5 gave us 11. Voila. So now we have our table of values. Now we have our table of values. So once you have your table of values, means you are ready to plot your graph. You are ready to plot your graph. So we'll write it down. Number 3. Now we want to plot our graph. We will choose a suitable scale. A suitable scale. So now we have values. We have these values and we need to now represent them on the graph. We have to choose a suitable scale. What is a scale? A scale is a reduced or increased representation of an actual figure. Okay? What is a scale? You say a scale is, in graphing, is a reduced or increased what? Representation of physical size. Okay, so what if in our scale, in our table, we have something like 1,000 kilometers or 100 meters, okay, and your graph is not more than 15 centimeters. Your graph sheet, if you have a graph sheet, it's not bigger than 15 centimeters. A small sheet of A4 paper. How do I put 100 meters? You know 100 meters race. How do I put it inside here? That means I have to reduce the size. Reduce the size with a formula. That reduction now is what we will now put on the graph, which is the same size but a reduced or a minimized level. Okay, so now we have hold on. We have the table. This is our table. Now we know that X ranges from where? From -5 to 5. And we know that Y ranges from -9 to 11. Can you mute your mic? Mute your mic. Thank you. Okay. So now this is the range. So we have to find a way to put, this is the maximum, this is the minimum amount that will be on x-axis. This is the maximum that will be on x-axis. While this is the minimum that will be on y-axis, and this is the maximum that will be on y-axis. Okay? So now we have to find a way so that all these points will enter inside the graph. So I'm going to choose a 1 scale, a 1 centimeter. My scale will be what? 1 centimeter. Sorry, my pen is shifting. 1 centimeter, 1 unit to 1 centimeter. 1 centimeter to 1 unit. Okay, so now this scale that you're writing is 2 marks. This is 2 marks. When you're plotting your graph, your scale is 2 marks. If you don't write your scale, you will lose all those marks. Okay, your table should be like, let's say, the table should be like maybe 10 to 15 marks. Your scale should be like 2 to 3 marks. 2 to 3 marks. So if you plot a graph, you do not write scale, you have missed 3 marks in that question. Okay, so now let's go ahead. What do we have next? So now we have gotten the scale 1 to 1, 1 centimeters to 1 unit. Means I'm not increasing anything, I'm not reducing anything. I'm using the real scale. I'm using the real scale. So now let's go ahead. Let's move this table. I will copy this table because I need to be seeing the table while I am plotting. Copy. I will move to our graph. So this is our graph. This is our graph. Can we all see this? I'm sure we can all see it. Okay, thank you. So this is our graph, but I can see that this graph is not wide enough. Let me see if I can increase it. Oh, undo. It is shaking. So we're going to copy and paste. Copy and paste. So I'm trying to increase the size of the graph. Trying to increase the size of this graph. Okay, now we have a bigger graph. Okay, I have a bigger graph. So our table, I will shift our table to this side so that I can continue what I'm teaching. I just want to copy this table. Ooh. Copy, paste. Ooh, undo, undo, paste. Okay, so now we have our table copied here. We have our table here. So now let's go ahead and try to plot the graph. We have the table. So the next thing is to plot the graph. Okay, so looking at this graph, you see that this graph is a centralized graph. Why is it centralized? Because it has an equal spread across x-axis, y-axis. The negatives are equal. The positives are equal. Okay, the y-axis has an equal spread and the x-axis has an equal spread. So this graph is going to be at the center. It's going to be at the center of our table. So we'll now draw our line. You use your pencil or your pen to draw your line. This line stands for the x-axis. It stands for the x-axis. Then we'll draw another line on this side. We'll call it the y. Sorry, it stands for the y-axis. This one we're drawing now is for x-axis. Okay. I hope we all know our axis. Please, if you're hearing me, type in the chat that you're hearing me. Okay. So now we have been able to construct our x-axis and our y-axis. So the center, of course, I will use blue. The center will be 0. The center will be 0. Yes. Okay, thank you. The center will be 0. Then we'll also indicate this as okay. So what I'm going to do, I will shift this graph out a bit. Let me shift it out so that we can see everything. I want to shift it out. Okay, good. This is good. Okay, now increase it. So I'm going to write what? Y-axis. Y-axis. Then over here, I will write my scale on top. Scale. scale. So now the scale can have two, we can have two scales for the x-axis and scale for the y-axis. Okay. So my x-axis scale is what? 1 centimeter represents 1 unit. My scale for the y-axis is 1 centimeter represents 1 unit. Another way to write it is to write 1 to 1. 1 to 1. Okay? 1 to 1 means I'm not changing anything. I'm not increasing, I'm not reducing anything. Then the next thing we'll do is to write the numbers on the axis. We'll write the numbers on the axis. Now, 1 centimeter is this box. Just when you see this box here. I don't know if you can see what I wrote. This box, this space represents 1 centimeter, right? This space you're seeing represents 1 centimeter. If you are seeing what I'm telling you, please comment in the section.
Sorry, ma'am, please, where did they comment from, sir? I can't even see anything on my screen here. Okay, no worry, I've seen it.
Okay. Just,
I've seen it.
I'll write a comment.
I've seen it.
I'll write a comment. Okay, thank you. Okay. So thank you for that. Okay, so one section is 1 centimeter. This section I showed you now is 1 centimeter. This whole box is 1 centimeter. Do we understand? Good. I suppose we understand. Okay. So now we're going ahead to label, because you have to label your graph accordingly, according to what is on your table. So we know that our range on our table for x-axis is what? Is 9 and 11, minus 9 and 11. So we'll label. This first one we'll write 1, 2, 3, 4, 5, 6, 7, 8, 9. It's like our graph has extended more. That means there's a point on the x-axis that is more than what we have. Right? Oh, yes. Then you go to this other point, the negative section. You go there, go to the negative section, and then you start to label. You start to what? Label. So you have minus 1. We have minus 2. You have minus 3, minus 4, minus 5, minus 6. And what again? What do we have again? Okay. We have minus 7. Minus 7. So this point is what? The minus y axis, minus x axis. Minus x axis. So now we have to now move to the y axis. Okay? And we label the same thing according to our scale. Okay, so far it was 1, going upward, 1, 2, 3. Listen carefully, because the truth is that you can draw your graph by yourself. Nobody is going to draw your graph for you. 5, 6, 7, 8. Okay, our graph is going to extend above. According to the table of values, y-axis reach up to 11, but we have 8 here. So that means you need a bigger graph. Most times the graph that I'll be giving to you can get up to 12. Okay, but if it will not go up to 12, you have to change your scale. You have to change your scale to a smaller number. To a smaller number. I don't think I'm thinking whether we should change our scale to a smaller number. Okay, let me see if we can do that. Okay, so I'll change the scale to, for y-axis, for the y-axis only, I can change the scale to let 2 centimeters represent 1 unit. Let 2 centimeters represent 1 unit. Okay. Let 2 centimeters represent 1 unit. So I'm going to do it like this. So am I on track? Am I on track?
I'm not seeing your chart.
You're
On the
not seeing my
y-axis, what are
chart.
you using? I can see it now. On the I can see it now.
I said on the y-axis, I'm using a different scale. I'm not using the same scale with the x-axis. Am I on track for that?
If you're using 1 centimeter to 1 unit, you're on track.
Yeah.
Hello, ma.
But for
Hello, ma.
y-axis, I'm using 2 different scales for the axis. Do you understand me? I'm not using the same scale.
Okay. Okay. Then
I said I'm not using the same scale. Can you hear me?
yeah, you write it on
For 1 unit.
On the y-axis.
Okay. Okay. Thank you. I just wanted to be sure that I'm on scale. I'm on track. Okay.
Right.
So we will now write, because it's now 2 centimeters to represent, sorry, 2 units, 1 unit to represent, sorry, I missed this. Let's correct it. It's 1 centimeter to represent 2 units. 1 centimeter to represent 2 units. Okay, so that means on 1 centimeter, I'm going to put 2. I'm going to put what? 2 here. The next one will now be what? 4. Right? Under will now be -2.
Yes.
The next one will now be -4. Okay? Then the next one will now be 6. So you keep on putting the units according to how it was written. I said 2 units, so I'm going to put 2 units. If I said 10 units, I will now write in tens, 10, 20, 30, 40, and so on. So now that I have increased the units, if you see, I will now be able to accommodate up to what? The amount we have on the table of content, 12. I hope we're all following, the students. I hope we are following.
Yes, ma'am.
If we are following as a student, please type in the chat section. If you are following, type in the chat section. You see, it's a process, so I have to take my time to explain everything accordingly. So this is the negative y-axis. The negative y-axis. So let me reduce this. So as you can see, the graph, our graph is set. Our graph is set. We have put all the scales and we have put all the numbers on the axis. Okay, so now it's time for us to plot the points. Plot the points. That is the next step. Okay, after writing the scale, the number of the axis. Then the fifth point is to plot. Locate the points. To say plot the points or mark them on the graph. We know from table of values, right? Table of values. That is how we got our points, our values. Okay, so the first point is what? -5 and what? The first point is what? -5 and -9. That is point 1. Okay, that is point 1. Can we see my marker very well? -4 and what? -7. I'm getting these things from the table. I'm getting these values from this table, the table that we have derived. The next one is what? -3 and what? -5. The next one is what? -2 and -3.
Yeah.
The next one is what? -1, -0, 1.
0, 1.
The next one is what? 1
and 3.
and 3. Yes. The next one is what? 2, 5.
And 5.
And the next one is what? 3 and 7.